So today we are talking about probability. You guys know a little bit about that already. You know, if you have a die, how many faces are on a die? Six. And if I wanted to roll a 4, what's the probability that it lands up being a 4?
1 out of 6.
1 out of 6 is only 1 4. There are 6 faces, okay? So this first example, it says a leaf is blown into a hopscotch core and it lands on one of the 6 squares of the T-shaped figure to the right. It is then randomly blown to an adjacent square. What's the probability that the leaf ends up on a red square? I know you don't see red in your picture, but you can see it up here. What is the probability that the leaf ends up in a red square? 1 out of 6, because how many squares are there?
6.
How many red ones? Let's keep it moving, okay? It says the art teachers at a school plan to take 300 students on a field trip to an art museum. One teacher found that 3 out of 36 students could identify a painting by Picasso before the field trip. Based on, it says P parentheses, students identifying Picasso's painting. What do you think that P stands for? No, not Picasso. Probability. So based on the probability of students identifying Picasso's painting from the teacher's class, predict how many of the 300 students would be able to identify a painting by Picasso before the trip. Any suggestions on how we could set this up to figure out how many of the 300 students will be able to identify a painting by Picasso? Sam?
Divide 300 by 36 and multiply by 6.
Divide 300 by 36 and then multiply by 6. How did you figure that?
Because if you multiply 300 by 36, you see how many times 36 goes into 300.
You said multiply or divide?
Divide. You see how many times 36 goes into 300.
Mm-hmm.
And then if you multiply that answer by 6, you can figure out how many students on average.
Okay.
You know.
So what is 300 divided by 36? 8.3 repeating. 8.3 repeating. Okay. Times 6 is 50. So is that, you can figure out that many students, so it's 50? Interesting. Interesting setup there. Okay. No, that is right. It is 50 students. Mm-hmm. Did everybody follow her logic?
I don't know why she did that.
Okay. There's another way you can actually do this, okay, and it does involve probability. Just said that 6 out of 36 students could identify a painting by Picasso. 6 out of 36. 6 out of 36. 1 over 6. That's what that reduces down to be. So 1/6 of the students are able to identify Picasso's painting. Okay, so that's 6 out of 36 or 1/6. Now what you can do, another way you could do this if you didn't quite understand this, was that there were 300 students total. And you're looking for how many out of those 300 could identify Picasso before the trip. So you can set up a proportion and cross multiply. 1 times 300 is 6 times x is. So if I divide by 6, you get 50. So it works both ways. Okay? This one here is using the probability and proportions together. However, here you had 300 students total. You only took a sample of 36, so dividing and then multiplying by 6, that also works as well. Questions? Any of these, whenever it asks you for like an actual number out of a big group and they had a sample, like here they had 6 out of 36, you can always set up a proportion to figure this out. Okay? The next one. Suppose you roll a number cube, a die. What's the probability that the number is greater than 1? 5 out of 6, because there's 6 numbers on it. Probability that is greater than 1, that's 5 numbers out of 6. Find the probability that is less than or equal to 4. 4 out of 6. 4 out of 6, because it's less than or equal to, so we're including 4 in this process. Are there any questions so far? Okay, well then take a moment to do the last 3 slides that are on this page, okay? So you have a spinner. What's the probability that you land on a 6? 1 1 out of 6. What's the probability that it's not a 4?
5 out of 6.
5 out of 6. What is the probability that you land on a 2 or a 3? 2 out of 6. It says 2 or 3, so that means you can either land on 2 or on 3, so that's 2 spaces out of the 6, which reduces down to what? 1/3. What about this last one, the probability that you land on 2 and 3?
0, because you can't land on both.
0. You can't land on both 2 and 3.
Unless you've got like a super multi-skill die.
You could land on the line.
Nobody counts that in real life.
Or you actually would spin again in that case.
Suffer.
Over here, you have a sock drawer containing 2 red socks, 6 white socks, and 4 blue socks. You replace the first sock in the drawer and then choose again. How many socks are in this drawer? There are 12, okay? So your denominator should be 12 in a lot of these situations, okay? Find the probability that you have a red sock. 2 out of 12 reduces down to be what? 1/6. Okay, you have 2 socks in the drawer.
So
Out
we're
of
at 0.
12 total. So 1 out of 6, that is a 6. What's the probability that it's a white sock or a blue sock?
10, 12.
10 out of 12, which reduces down to be what? 5 out of 6. Okay? What about the probability of getting a green sock?
0.
0. Why is it 0?
There's no green socks.
There are no green socks. But what about the probability that you have a red, white, or blue sock? 1. Because how many? That's all the colors that were in there, right? 12 out of 12. 1. Okay? And the next one, it says, Deidre is in the French club. There are 23 students in the club. 3 of them are picked at random to attend an awards banquet. What's the probability that Deidre will not be picked to attend the banquet? Why silence? What's up?
Well, the 3 of them will be picked turn throws me. If they didn't say that, I can figure it out. But I get the feeling that when it says 3 of them will be picked at random, it is necessary.
So, okay, it says 3 of them will be picked at random, right? So, 3 will be picked. That means how many won't be picked? 20. So, what's the probability that Deidre will not be picked? 20 out of 30. Or, not 30, I'm sorry, 23.
We just gained some.
So, yes, that 3 was helpful for us, because without it, we wouldn't know. Now, something else that you could also do sometimes, okay, go ahead and put that out there, is that you know that 3 out of 23 are going to be picked, okay? Are going to be picked. So to figure out the amount that isn't going to be picked, you can always do 1 minus that, okay? Because technically, it's known as the complement. The ones who are being picked, that's the event. The ones who aren't being picked, that's the complement. And so you still get 20 total, 23. A bag contains 12 pieces of fruit, 7 apples, 3 oranges, 2 bananas. John is given a piece of fruit, and then Tori is given the next one. What's the probability that John will get an orange?
3 and 12.
No, 3 out of 11 because if he gives the first fruit away, he's not limited on how much is left.
Let's read this again. It says the bag contains 12
John
pieces of
picks
fruit.
the first. Yeah.
John picks the first.
So
it'd be 3 out of 12.
Um,
Yeah, don't let any of the extra wording throw you off. Yes, Tori is given 1 next, but the fact is Tori is second. Okay? Now, if it did ask you, what's the probability that Tori gets an orange if John got an orange? Well, then that's something a little bit different, because if John got an orange first, how many fruit is left in the basket? There would be 2 oranges left, because 1 orange will already be gone. By how many fruits are left in total? 11. So if it says something about Tori getting an orange after John got an orange, then you would need to take that into consideration. Okay? But it was just actually asking for what was the probability that John got an orange, which is 3 over 12. That reduces down to be what? 1/4. Okay? Keep it moving. In a random sample of 508 calculators, 6 were found defective. A factory produces 3,556 calculators each day. Predict how many are likely to be defective. Very similar to that second example of the students and Picasso. How can I set this up? Awesome. Yes, probably need to calculate some big numbers.
2.
Cross multiply. What's 6 times
21,336. And you get a lucky number of 42. You're up.
would be considered defective, okay, using our probability setup. Questions on that? Okay, I'll do about 2 more with you, then I want you guys to do the rest on your own, okay? Here we go. You roll a number cube, number 1 to 6, then you spin a spinner with 5 sections, each with a different color. I know you can't see the colors that well, that's why they're up here. The spinner has 3 the colors you see. P, 2 in red. What's the probability that you get a 2 and a red?
Is that asking for the probability of 1 and it, or would we take the, like, since there's 6 and 5, and put them together?
You treat them individually. Because here, this one does have 6.
Yeah.
What's the probability of getting a 2? 1 out of 6. Over here, how many sections do we have?
5.
And what's the probability of getting a red? 1. So to find the probability that you roll a die, get a 2, and then spin the spinner and get a red is the product between the 2 probabilities, which is when you multiply fractions, you multiply straight across. So 1 times 1 is 6 times 5 is
130.
1 out of 30. Okay? So whenever you have 2 different events going on, but you want the probabilities that you get 1 from each event, you just multiply them together. Okay? Now that's your product. Over here, you roll a cube that has numbers 6, 15, 6, 18, 15, and 18 on it. Then you spin a spinner that has 3 sections. The letters in the spinner are J, C, and D. What is the probability that you have a J and not a 6? Okay? Very similar. This cube die thing that has these numbers on it of 6, 15, 6, 18, 15, and 18. What's the probability that I don't get a 6? 4 out of 6. Because I
2 6.
not a 6. Okay? And this reduces down to be what? 3. What's the probability that I spin the spinner and get a J? 1/3. So to find the probability that I spin a J and roll a number that's not a 6, what do I do to these 2 probabilities? Multiply them. Multiply straight across to get what? 2 out of 9. That's the probability that I'll spin a J, roll a number that's not a 6. Questions? Take about 2-3 minutes to do the last problems that are in this packet, and then we'll check them, okay? So about 3 minutes. You want to compare answers? All right, let's see how well you did. I know some of you guys didn't get a chance to get through all of them. That's okay. Got plenty of opportunity on your homework. You will flip a coin and toss a 1 through 6 number cube. What's the probability of a head and a composite number? We already went over composite number. Composite numbers are numbers where they're more than just, it's just one in itself that multiply to give you that number. Okay, you have prime numbers and composite numbers. So on a die, which numbers are composite numbers? 4 and 6. So that is how many numbers out of the 6? 2 out of the 6. All right, which reduces down to be what? 1/3. What's the probability of being ahead if you flip a coin? 1/2, because there's 2 sides. One's the heads, one's the tails. What do I do to the 2 probabilities? Multiply them to get 1/6. Very good. Over here, a number cube is rolled and a coin is tossed. What's the probability that the number is greater than a 4 and you get tails? So, what's the probability that is the number greater than 4? 2 out of 6. We reduce it down to be what? What's the probability of getting a tails? So, what's your probability? 1/6. Right there, you got that right. Both of those. Awesome. Over here. Suppose you choose a sock from a drawer containing 6 red socks, 2 white socks, and 4 blue socks. You place the first sock and then choose again. So I'm making 2 choices. How many socks total? 12. What's the probability that I get a white sock? 2. What's that reduced down to be? 1 to 6. And then I get a blue sock. How many blue socks are there? Out of how many? What's that reduced down to be? 1 what? Third. What do I do to the two probabilities? So then that'll give me the probability that I draw a white sock, and then I draw a blue sock, which is what? 1 out of 8. Suppose you choose a sock from a drawer with 8 red, 10 white, and 4 blue. How many socks is that? 22. You replace the first and then choose again. So what's the probability that I draw a white sock first? Does that reduce to what? 5 out of 11. And then I choose again and I draw a blue sock. How many blue socks are there? Out of, can I reduce that to get what? So what do I do with the probabilities? Multiply them. Then I'll give you the probability of picking a white sock and a blue sock, and that is 10 over 121. You know, if you reduce before you multiply, then it'll say you're reducing at the end with those bigger numbers. Okay? Let's keep it moving. Couple more. It says a coin is tossed and a number cube is rolled. What's the probability to get a heads and an even number? How'd you get that?
1/2 for the coin, and then the even number would be 3 out of 6,
Which is 1. Very good. 1/4. Okay, you get a probability 1/2 for tossing a heads, and then 1/2 for an even number because there's 3 even numbers out of 6. That reduces. What about this one? Who has this one? Will you tell me this one? Lacey, how'd you get that?
There's almost like 1/2 because, or 1/2 by 1/2 because it's 3 out of 6 times 3 out of 6, so there's 3 odd numbers in each one.
There you go. There's 3 odd numbers in each one. So 3 odd numbers out of 6 gives me 1/2. And I'm trying to figure out, okay, what's the probability that an odd number will show both times? So that's 1/2 times 1/2, which is 1/4. Are there any questions? The next two are different because you got to take into account that for both of these situations, I'm not replacing the card, I'm not replacing the fruit or anything like that, okay? So it says a bag contains 12 pieces of fruit, 7 apples, 3 oranges, and 2 bananas. John is given the first piece of fruit, then Tori is given the next. I kind of hit on this already. What is the probability that John will get an orange and Tori will get an apple? What's the probability that John will get an orange? 3 out of 12. Because there are 12 fruits in there, there's 3 oranges. What does that reduce down to be? 1/4. Then Tori gets an apple. How many apples are there?
7.
How many fruits are there now though?
11.
11. Because once that one fruit was given to John, there were only 11 fruits left. So you're going to multiply 1/4 by 7 11ths. And if you multiply straight across, that's what? 7 over. Okay? Please make sure you reduce. If you don't reduce throughout your problem, reduce at the end though, okay? You have 3 $1 bills, 4 $5 bills, and 2 $10 bills. How many bills do you have total? 9. I select the bill at random. Without replacing the bill, you choose the second bill. What is the probability that I get a 10 and then a 1?
2 out of 9.
2 out of 9 is the first thing because I'm drawing a $10 bill.
3 out of 8, where 2 going on.
And then 3 out of 8 if I go back in and draw out a $1 bill. I started with 9. Once I took 1 out, I was left with 8. Multiply them straight across. What is that?
6 out of 7.
6 out of 72. Can I be reduced? And the last one. Everyone knows there's 52 cards in the deck, right? How many suits are there? 4. And how many cards are in each suit? How many cards are in each suit?
13.
Around the ace.
Don't worry about the ace. Here's 3 base cards, and then, okay. Probability that you draw a 2 and then a 3 if the first card is not replaced.
So first will be.
For the 2, it's 4 out of 52.
4 out of 52.
Which one reduces to 2 over 23,
1 over 13.
which is, wait, what?
Mhm.
Yeah,
Did I do something wrong? Oh.
The next one is 4 out of 51 because if I took the card and I didn't replace it, that leaves me with 51 cards left. But there still are 4 threes in that pile. So I'm going to multiply 4 over 51 by 1 over 13, and that's going to be 4 over. Is that reduced? And there you go. Probability. Lots of examples. Hopefully re-jog some memories about probability. Maybe even learn something new. Okay? We have multiple things going on, multiple events.